While the bulk of all the gravitational force that we have measured in the universe, about 85% of it arises from the substances that do not otherwise interact with the matter or energy. We are essentially clueless. So this missing mass problem was first fully analyzed in 1937 by the Swiss-American astrophysicist Fritz Zwicky. Zwicky studied the movement of individual galaxies within a titanic cluster of them located far beyond the local stars of the Milky Way that trace out the constellation Coma Berenices. The Coma clusters, as we call it, is an isolated, rich-deep group of galaxies 300 million light-years from Earth. Its 1,000 galaxies orbit clusters moving in all directions, using the motion of a few dozen galaxies as tracers of the gravity field that binds the entire cluster. Zwicky discovered that their average velocity had a shockingly high value. Zwicky inferred an enormous mass for the Coma cluster. As a reality check on that estimate, you can sum up the masses of each member galaxy that you see, and even though Coma ranks among the largest and the most massive clusters in the universe, it does not contain enough visible galaxies to account for the observed speeds Zwicky measured. And when we examine the Coma cluster, as Zwicky did during 1930s, we find that the member galaxies are all moving rapidly than escape velocity for the cluster. The cluster should swiftly fly apart. But the cluster is more than 10 billion years old, which is nearly as old as the universe itself, and so was born that remains the longest standing unsolved mystery in astrophysics. Across the decades that followed Zwicky's work, other galaxy clusters revealed the same problem, so Coma could not be blamed for being peculiar. In the year 1937, Rubin had been studying the rotation of galaxies such as our nearest large neighbor, the Andromeda galaxy, and discovered something very strange. Now, before proceeding further in the video, let's understand the basic concept. Now suppose this is a rotating disk, or you can say CD. A point on the disk that is nearer the edge travels the faster than a point near the center. Now this is certain to happen as the further out apart from the disk is, the greater the distance that the point has to travel in any particular elapsed time. With a more loosely connected collection of matter-like galaxies, it is possible for material at different radii from the center not to follow the same pattern as a solid disk. We would usually expect that after the time the galactic would settle down to rotating in a pattern where the moving away from the disk of the galaxy after an initial fast growth. The speeds tails off for the stars that further out. This results in a rotation curve that is the standard behavior predicted by the Newton's law of gravitation. Now this is the graph. But Rubin and Ford found the unexpectedly parts of the galaxies near the edge were rotating at the close to the same speed as the parts near the middle. The most obvious reason that this would happen was if for some reason there was a lot of matter distributed spherically around the outside galaxy in what is known as halo. So Rubin and other astronomers began to collect the data on other galaxies, finding a similar effect in each case. What's more, just like Zwicky's cluster, they found that galaxies were rotating sufficiently quickly that they should have flown apart if they only contained the visible matter that appeared to make up them. Rubin estimated that there was in reality around 6 times as much matter in the galaxies than appeared to be the case from the visible material. And using the measurements of the impact of gravitational lensing provided further support for the existence of dark matter. So, what was it made of? It couldn't simply be the traditional components of stuff, quarks and electrons, because they do interact electromagnetically. Electromagnetically speaking, it's as if dark matter doesn't exist. Yet, gravitationally, something is producing the effect that is ascribed to it. So in the next video, we'll discuss what is dark matter made of. Thanks for watching the video.